All right, this is exercise 2 of Fusion 360. We're working with constraints. First constraint is horizontal and vertical. So for this exercise, you'll be making 3 line segments. Oh, by the way, this should be taken in after you've listened to lesson 2, in which I talk about all this stuff. I am just going to be going through the exercise that you need to get in-class points. So this is exercise 2. 3 line segments. If you just make 3 line segments and add the horizontal vertical constraint, you will get 3 horizontal and or vertical lines depending on how close these were to horizontal and vertical. Please do that with a rhomboid as well so that you end up with a nice clean square to the axes rectangle. And then this one's a little trickier. Instead of making the lines part of horizontal and vertical, you are going to select 2 points for horizontal and vertical. And this will allow you to make a shape that you can then flex, and it follows the rules where the space, the line, the invisible line that goes between those 2 points must be either horizontal or vertical. Okay. Next is coincident. You make 3 line segments. You make the points coincident to each other. You will get a triangle. Yes, not the fastest way to do this, but go through the long way anyway. You can also make a point coincident to a line. Please do that, and note that you can now move this around. If you grab it by the point, it'll change the angle. If you grab it by the whole thing, it will move across the line. And also you should note that just because it's coincident to the line doesn't mean it's fixed to the line segment. This is just a segment. The line actually goes off to infinity, so it's still stuck to the entire line. All right, moving on to tangent. Make a shape that looks like this, and if you make this curve tangent to this line, it will give you a nice smooth transition. Make a circle and a triangle. If you make each leg tangent to the circle, you will have the circle perfectly nested inside the triangle. All right, moving on to equal. If you make a triangle shape and make all the sides equal to each other, you will get a equilateral triangle. Note that this side is equal to this side, and this side is equal to this side, so this has 2 groups. You do not need to make this side equal to this side because that's redundant. It's already set with those 2. This form is a little trickier. If I change this right now, you can make this all kinds of different shapes. But if you make this line equal to this line equal to this line, and this line equal to this line, you should get, it should stay the same shape, roughly. Not the same proportions necessarily, but the same shape as you scale it, because as you change the length of this up here, it's going to change the length of this one down here. All right, now we're on to parallel. 4-sided rhomboid figure. Make the top parallel to the bottom, the sides parallel to each other, and now you have a constrained to it being parallel parallelogram. Perpendicular, pretty simple. You have your lines that are otherwise free to move about in relationship to each other. You make it perpendicular. This is now fixed to a 90-degree angle. This is different than horizontal and vertical because you'll notice that this line isn't vertical. If I try to make any adjustments to this, it just moves it up and down on that edge. You can do the same thing within triangles. If you want a right triangle, you can take this non-right triangle and just make this leg perpendicular to this leg, and Bob's your uncle. All right, So now we're going to go to fix and unfix. If you need something to stay in one spot, this is the key for it. The example is, again, another rhomboid. I fixed this corner, so now wherever I move this, it doesn't want to go anywhere. This corner is staying put. If I try to move this one, you'll notice that it kind of moves other things. So that's fixed. These two line segments have their bases fixed over here. Notice how they turn green? This is going to be very useful for you to pay attention to because every once in a while something becomes fixed and you don't know why it's moving the way it's moving. Check for the green spots. Notice I've also made these parallel, so if I move one, they both move like windshield wipers. All right, moving on to midpoint. Make a square within a square within a square. Doesn't have to be squares, can be if you want. And then apply a midpoint from the corner of one square to the segment of the other square, and you will get nested squares that stick together and will always be at the midpoint, halfway in between. All right, moving on to concentric. Make 3 circles, make them concentric to each other, and they're nested as such. This shape is a little more complex. We've got some straight lines, we've got some arcs in here, but notice that the arcs also have midpoints. These are sections of circles. You can make this concentric to this, and thus it will put it in a place where this curve and this curve are concentric to each other. This model isn't constrained in any other way, really, so it's kind of messy from here, but you get the picture. Collinear. So make a square, make a couple of line segments off of it that are otherwise coincident to the line on the rectangle. And then if you make this line collinear to this line, you can move them both. All right. You can also do the same thing to things that are not lines. So if you had 3 circles like this, which you will soon if you're actually doing this, which you should because you won't get credit otherwise, you can make this dot, this center point, collinear with this center point and this center point. Sometimes you have to click all 3 before it shows up. And now we have these 3 circles collinear from their midpoints. I have made this center fixed, if you see it, notice that it's green, so that it pivots. If that wasn't on there, these would slide up and down as a group. That is collinear. That is all for exercise 2. Please take screenshots and email them to me to get credit. Thank you.